Thank you. All right, thank you. So welcome to the talk about Flutter in finance, 20 minutes to banking grade security. So who heard about Flutter before? Yes, it's very important. Okay, great. Who did any Flutter? Like has any Flutter experience or any apps in their company? Okay, great. So let me just introduce myself and the company. So who we are? We are LeanCode. We are a software studio. We are known for Flutter. In the Flutter bubble, we are one of the leading software houses, I would say, agencies. And we were very early in the Flutter bubble. We are not only Flutter, of course, just like any other software studio, but we were very early in the game and also did some enterprise stuff. That's why we, for example, are a member of Polish Banking Association and do a lot of stuff related to large-scale Flutter. So large-scale Flutter means banking apps, fintech apps, but not only like manufacturing apps like you can see or some big tech projects. With that kind of projects, you have to be very opinionated on some choice of architecture and security and all that stuff considerations, because majority of these big companies and regulated environments, they enforce pen testing, security testing, and a lot of compliance related to this domain. We also are building the Flutter community. We co-founded Flutter Europe conference. We are hosting one of the biggest Flutter meetup in Europe, which is Flutter Warsaw. We come from Poland. This is a very important fact I forgot to tell you. We speak at many conferences. We have Google developer experts on Flutter, and we live Flutter. So why it's important? Because today I'm not a security guy. I'm a developer. I'm actually a head of Flutter department at my company. And I would like to tell you a story from the developer perspective, how it was for us with Flutter and security and our challenges and things that we observed and myths that we had to cope with. We also conducted something called Flutter CTO survey. And throughout these results, one of the biggest concerns that CTOs were reporting was meeting non-functional requirements like security, because there were lack of materials on the internet and people were feared about Flutter in terms of secure environments or regulated environments, and many people are scared about using some non-native, I would say, non-default technologies in that space. And this is what I would like to talk about today. And also, we created a roadmap about migration to Flutter for companies that would like to migrate or want to navigate this migration. And together with Talsec, they helped us they created a step number 16, which is application security and compliance, a whole chapter about what you should consider when using Flutter in secure environments and regulated environments and so on. And why it's important, and what's the problem? The problem is that many times we hear the myths about cross-platform. So cross-platform stuff is implicitly much less trusted by a lot of people. When we talk to clients, when we consult, when we work with them, or we do audits, because we also do code audits, people are very scared about cross-platform. Hearing anything about cross-platform, doesn't matter if it's Flutter or React Native or WebView apps. Cross-platform or non-native is something like a warning light in their heads. And many times we hear some objections like Flutter is not native, and it means Flutter is not secure. And I'd like to talk a bit about it today. So what's Flutter for people that don't know? Flutter is an open source framework for building beautiful natively compiled multi-platform apps from a single code base. That's their official statement. So how it works, it's combined of a framework that's it's built in Dart. Dart is a language created by Google that's used mainly for Flutter apps, and there's an engine written in C++, which is also cross-platform. Like C++ is one of the most cross-platform languages, I would say. And thanks to that, when you combine it with Embedder and Runner, which is your platform, like an Android app or iOS app or a web app or a macOS app, Linux app, Windows app, together with Dart framework that's cross-platform and C++ engine, you can have an app compiled on that platform. So what's Dart? Dart is a language. So what's important about Dart in terms of security? It's a language that has both just-in-time and ahead-of-time compilation. Just-in-time compilation for hot reload and all that developer experience stuff. But what's important in terms of running in production is it's compiled to native machine code for performance, but it's also better for security, I guess. I think it's harder to reverse engineer in terms, like if you have no bytecode or any intermediate language. It's also type safe and sound null safe. Garbage collected, and what's important is that its concurrency model is very simple. You can only pass messages across isolates. You have no shared memory, so it's kind of easier for us engineers to not make mistakes that are vulnerabilities in terms of shared memory and all that stuff. So why I'm telling you this, it's that you can see it's not a glorified web view. It's not every cross-platform technology is the same, and here it's a whole different technology than just embedding a web application inside your app, and it's also not interpreted JS code that you load the code file from your bundle. It's literally native app like Android app in Kotlin or iOS in Swift, plus your Dart code compiled to machine code. This is your Flutter app. So what was our experience with AppSec in banking with Flutter? So what was the first and foremost experience for us regarding Flutter in banking was a project for Crédit Agricole. So Crédit Agricole, a Polish branch, they decided to create a new app from scratch. In Polish market, mobile banking is very competitive because everyone uses mobile banking for all sorts of public services. You can authorize with the mobile banking app to most, I would say, social and public services. You can literally use your banking app to authorize to, I don't know, register for voting or stuff like that, apply for a lot of stuff. So people just use it a lot, and it's very competitive. And they had a native app that was already a couple of years old, and they wanted to renew the experience, wanted to do the UX and all that stuff, which is, Flutter is excessive in delivering great consistent UI because it's working on the GPU layer, and you can do a lot of UI magic. But they did something that was very bold back then, because they decided to go with full Flutter. A lot of apps were just adding Flutter to their apps back then, even if they were from fintech or regulated environments, but they went full Flutter. So full Flutter from scratch, pretty much no native views or stuff like that, just Flutter. And it was a huge thing. Even we had a showcase on official Flutter website. So if you're interested with that, there's a video about it, and you can watch it later. But what was the story is that it all started in 2021. it was very bold to move to cross-platform and also Flutter, because back then Flutter was not so mature. It was 4 years ago, and they created a version 1.0 in about 9 months. We created with them, of course. And at the beginning, they had the issues with ranking of mobile apps. We have something like that's organized by Newsweek, and they rank the apps from like customer experience. After 4 years, it's still there. It's developed actively. We maintain it. There's a lot of new features. They also used it to experiment on web, which is very interesting. It has one of the highest ranks in the Polish mobile banking market. It grew the user base, and also they are very proud of the metric called time to wallet, which is how fast you can see your balance in the app, because people want to the quickest thing they want to do is check their balance. So to do that, we had to meet a lot of non-functional requirements like security, and we had to fight a lot of myths that were also within this organization. So that opened the doors for us to create more, to participate in more banking experience. We did another bank. Also, we helped Virgin Money, a UK bank, to provide their Flutter experience. We also helped some cryptocurrency wallets and so on. And why was it secure and what was hard? Because there were many objections in all of these banking organizations, especially from people that worked before on native apps, and they were throwing objections at us. So first, this AOT compilation plus obfuscation that's already built in Dart world was very handy. We had pretty much during the pen testing, we had no issues regarding any code injection thing or anything related to the Dart runtime itself. There's also it's very helpful that there's no reflection in Dart, so you cannot see any runtime. In the runtime, you cannot see any information now about the types. So it's also harder to make this kind of mistake and error. So that's why we didn't have any of that code interpreting errors or vulnerabilities come from the pen testing. Something that was raised by, maybe not raised, but pen testing teams contacted with us about the networking stack, because they were not sure how to approach that, because when you use Dart, you have another networking stack. You don't use OK HTTP, for example, or any Cupertino like URL sessions, any of the native stuff that are native in terms of Swift or Kotlin. It's rather more low level, so you use it directly from Dart. But there were some things that were required. For example, in one bank we had to do this SSL pinning from the domain certificate. In another bank there was like more of a root certificate pinning, or like intermediate, in the certificate pinning. It was all possible to meet these requirements. Also, public key pinning was just a straightforward thing. There were no issues with that. What was very handy was that there also were some find proxy callbacks, because during pen testing, when we are engineers, many times we are approached by security people to let them pass some proxy data, to check man-in-the-middle attacks or stuff like that. So there were no issues with that. Actually, it was very, very handy. And then we discovered also that there was introduced something like a easy API switch for the HTTP clients, which is that if you want to really use native HTTP stack like OK HTTP or Cater or any of the iOS clients, you can just plug and play. So it's very, very easy. And what was actually the main the major thought was that you can very easily use native stuff, and under the hood you just use a lot of native stuff. So a lot of Flutter plugins just use Kotlin plugin or Swift plugin under the hood. So, for example, there's something like Flutter Secure Storage, and it just uses a key store or encrypted shared prefs on Android and a keychain in Swift. So basically, you have to also have native knowledge. This is very important because you have to know what your package uses. This is the most important thing because all of that under the hood is native. So if there are any, yesterday we had, there was a workshop about OWASP top 10 mobile vulnerabilities. So a lot of them were one-to-one. You could have them in Flutter because of the same system APIs. So this is very important to remember what you use under the hood. So of course you have to check the packages, but this is the same. You can use the same native API for keychain or key store, the same native API for biometrics or secure enclave encryption, stuff like that, hardware encryption. And also the same native third-party SDKs, which in regulated environment was very important because banks, many times they already have contracts with some companies about fraud detection, APIs, or know your customer frameworks, all that stuff, and they don't want to change it because you change the technology. So they want you to just use it, and many times they don't offer dedicated Flutter SDKs. They just offer Android SDK and iOS SDK. So you can just use it. I was approached by people that were spreading this myths that it's hard to integrate with native stuff. It's not at all. It's very easy and straightforward, and Flutter team makes it easier and easier to just generate those integrations so that it's less and less work. And we, in many banks, we used native fraud detection SDKs, know your customer SDKs, some fingerprinting and all that stuff, and it just works. And the same goes with Rust providers. We have used multiple Rust providers because, again, all the banks have different contracts and all that stuff. And although most of the things in Rust is native, there were some considerations regarding Flutter. For example, there were some Rust providers that had some false positives because of Flutter, and we had to gather this feedback, send it to them, and wait for the response. Of course, there's also Talsec, which offers treats Flutter as a first-class citizen, which is very nice because you can use Talsec Rasp, and it's already Flutter security Rasp. You don't have to think about would it work with Flutter. It also considers Flutter, so it's even much easier when you use Talsec Rasp. But what's important, and my final thoughts that I would to share today is that Rasp is only one of the things, right? And there are a lot of things in our engineering job about security. A lot of things that pen testing raises to us is beyond Rasp. Rasp is just the easiest part. Just to use some Rasp framework, this is the easiest part. But there are a lot of stuff related to how you architecture your code, whether you run some static code analysis against security vulnerabilities, or do you check for third-party vulnerabilities in your packages and libraries and all that stuff. And we also do a lot of app code audits, which are very comprehensive, but also touch on security. And what's not secure, and what we observed throughout many security audits that we had in code audits, and what we found, the most popular stuff, although it's very cliche, but it still happens. It's still the same. No matter if it's a code audit 5 years ago or a code audit tomorrow, the same things are still happening. So we see storing sensitive data in pretty public places like shared preferences or some unencrypted files. A lot of times we've seen very a lot of misconceptions about biometrics. This is something that's actually, I think, can work even worse in terms of safety. Like yesterday, there was a topic of safety, a feeling that users feel safe. And here, this is very dangerous in my opinion, because I've seen a lot of apps that are using biometrics. So the user can feel very safe and they feel like, you know, we have a biometrics authentication, so I feel very safe. But under the hood, this biometrics was using local authentication. So it's actually not encrypting anything with your personal data. It's not using biometrics to actually, you know, encrypt, decrypt any data. It's just, you know, an if statement that's checking if someone let you in. So it's very easy to work it around, and it's very insecure in terms of what happens next. Because if it's done like that, many times to actually log in somewhere, or, you know, sign in somewhere, you have to still have the credential. And many times what I saw is that people like developers have to store that credential somewhere to still use it after this local authentication biometrics. So actually it's even less secure, because they store my personal password and I can see, like, you know, the biometric prompt, so I feel safe as a user. If I don't know it, I don't know the implementation, I can see the biometric prompt and I think, okay, it's even better, this app is better than that because it uses biometrics. And actually it uses it as in a way that's even less secure, because it has to store my credentials. So inside code, there are a lot of misconceptions about what's secure and not. Especially when just using packages. Let's just use a package for biometrics, and this is a perfect example. Of course, there's a lot of also logging personal information all around. And as I said, storing passwords. Storing passwords, this sounds very unbelievable, but this is something that happens. I had that situation in the last year, I would say, even when doing some audits. So when you see all that stuff that I described, you might think it's not Flutter at all. All this stuff like storing in shared prefs, using wrong local auth APIs, you know, storing passwords, logging personal information, it's not related to Flutter at all, right? So it's not like Flutter is not secure. Actually, your code is not secure, like the people code that say that something not secure. So I think the moral is that we have to always think about each line of code. If it's secure, it's no matter how we do it and not what we use. It can be very secure with JavaScript. It can be very secure with web views. It also can be very not secure when using native apps, you know. And that's something that I think we engineers, especially like when we develop things, we have to think about, because pen testing or security tests are just, you know, just to prove us wrong and like tell us this is not secure, but it doesn't free us from thinking about it when we actually do the code and actually plan all the architecture, all the stuff inside the code. Right, thank you very much. And that's all.
Any questions to Mateusz?
Thank you. How do you approach dependency versions? Do you log your versions or not? Like,
sorry, which versions?
like dependency versions in Flutter.
Yeah, so we pin versions, especially in regulated environments, because it's very important to know what version exactly was compiled. And we also use some tools to check the license compliance with that versions. So it's also in the CI/CD pipeline, because it's another thing that's very important. If you don't pin it, you could have a case that someone changes the license, for example, and it's automatically pulled. So in this kind of environment, it's very important. So we use also CI/CD checks for that. So we pin the versions. Although we have logs, log files, Sometimes you might get into some trouble regarding transitive dependencies. So we enforce it. Either we enforce the lock or we pin the versions. Yes.
Thanks.
Any more questions?
Also now it's much easier because you have Dart workspaces. There is some question or not? Okay.
Ah.
You have the shop monopoly. I want to take it. All right. Thanks for the presentation. I have a fairly technical question. You mentioned that you could sort of flip between the native network implementations and the Flutter one. Is that a Flutter provided switch?
Yes, it's something that's pretty new. I think like it has a year or two, and it's just that the HTTP client API, like the interface of that, is just in the packet, in the official package, and default implementation is something called IO client, which is this low-level implementation. But they also, the Flutter team provided two additional implementations, which is Cronnet on Android and Cupertino HTTP, which uses URL session on iOS. And the thing is that they also implement the same interface, so you actually can change, 2 or 3 lines of code, and the rest of the app should work because it uses the same interface. And just under the hood, it would use another networking stack. And it's also very extensible. If you wanted to create your own implementations also, why it's important, it's because in some banks, we've met situations when the banks already have some core libraries. They have their own HTTP client already. They invested time and money in that, and they wouldn't like to rewrite it in Dart. So then it's much easier to just use it and still be very flexible about flipping it in the future, or changing that.
All right, thanks.
All right, thank you.